Hey, good morning, guys. Hope you're together doing good. Right. So today we are mainly going to talk about the main agenda is to have discussion around periodic table. Okay, so we will mainly talk about periodic table, how it is in detail. So let us first start with the matter. What is matter? Let us define matter. Matter is a matter is something which has mass and occupies space. Matter is something which has mass and occupies space, right? For example, this is a matter, this is a matter, this is a matter, I am a matter, sport is a matter. Everything which you see, we all are surrounded by lots of matters, right? We ourselves made up of matters. Okay, so matter is something which has mass and occupies volume. Let us talk about classification of matter in short. We will not talk in detail. So matter can be classified into two types, pure and impure. Pure matter, impure matter. Impure is called mixture also. But we are not going to talk anything about mixture or impure matters. So this is out of the scope of this video. So pure matter is of two types, elements and compounds. Both are pure form of matter. That means they are made up of identical molecules. So in this video we will mainly talk about elements and their fitment in a table called periodic table, right? So before I start uh, talking about periodic table, I think I should talk about the background a little bit, right? Elements have not been discovered in the order of any trained in their chemical properties or physical properties. I repeat, elements have not been discovered in the order of their physical properties or chemical properties. No, they have been discovered randomly in different parts of the world by different people, right? Okay, so after the discovery of 30 or 40 elements, group of scientists tried to arrange elements on the basis of the similarity of their properties. Properties means chemical property and physical properties. So after the discovery of 30 to 40 elements, group of scientists are try to arrange the elements, right, on the basis of their uh, similarity of property, right? So while doing that, they found few elements which share some common properties, and some of them have no pair, have no matching pair. Some of them had no matching pair, right? So this gave a hint to the scientific community that they should stick for more and more discovery of elements. They should stick for discovery of more and more elements, right? And probably they could get the missing pair. Fortunately, it worked in the favor of their ideas. So more elements were discovered, and they found that their ideas are working perfectly fine. So after arranging the elements on the basis of the similarity of chemical properties and physical properties, so what are the physical properties? For example, boiling point, melting point, density, these are called the physical properties. And chemical properties, electronegativity, electropositivity, right? Number of valence electrons, reactivity, chemical reactions, these are called chemical properties, right? So after the grouping of elements on the basis of similar physical and chemical properties, they attempted to create a table kind of structure, right, in which all the elements can be fitted together. They attempted to create a table like a structure in which all the elements can be fitted together. They called this particular table is known as periodic table. Periodic table. So can we define periodic table? Can you define periodic table? Yes, we do. So here I have written down the definition for periodic table. It's a tabular arrangement of chemical elements, right? It's a tabular arrangement of chemical elements. It's a grid kind of structure. Okay, it's a grid kind of structure. So I will try to make a grid here. Okay, just take a look here. So it's a grid. This is just it is just an example. It is just understanding which I am sharing. So these are called these are so these grids are made up of group columns, right? Vertical columns and horizontal rows, right? What we call rows, we call it period. So this is period 1. This is second period 2. This is period 3. And what are they? They are groups. So we will call it group 1, group 2, group 3, group 4, group 5. So it's a grid kind of structure. Periodic table is a grid kind of structure in which each of the elements occupies a unique position. I repeat, in which each of the elements occupy a unique position. Just a moment. Each of the elements occupy a unique position. A unique position, yeah, this is very important point. A unique position. They occupy a unique position. Each of the element occupies a unique position in this grid. For example, here is hydrogen, suppose. So you will not find hydrogen in any other cell. It's impossible. Because each of the element occupies a unique position. You will not find any duplicate elements in the periodic table. So for example, suppose just I am giving an example here. Suppose this particular cell is occupied by carbon. So you will not find element carbon occupies any other position. No. This is the unique position of carbon. You will not find any more carbon in the periodic table. Suppose excuse me, this is an element which is occupied by platinum. Okay, this is an element which is occupied by. This is a cell which is occupied by an element called platinum, Pt. This symbol is Pt. This is a cell which is occupied by platinum. This is a unique cell, right? You will not find any more platinum, Pt, in the periodic table. So that's what we mean. Each of the element occupies a unique position. It is simple. As per analogy, you can take an analogy, right? Consider xy axis. Okay, this is x, this is y. Okay, and if I give you the coordinates of a point, right? Let's say coordinate is 4, 3. So 4, 3 is the coordinate of this point. Okay, so you will say, okay, that means it is 4. It is 3, right? So if I give you the coordinate of a point, you can locate that point on the xy plane. So similarly, if I give you group number and period number, group number is analogous to y-axis and period number is analogous to x-axis. So if I give you group number and period number of any element, you should be able to find its position exactly, unique position in the periodic table. I will talk in detail about periodic table when I will discuss with the real actual periodic table, right? When I will discuss with the actual periodic table at the end of this session, I will show you the how a periodic table actually looks like. Okay, just one. So what is that? So we are done with the definition of the periodic table. Okay, so how many rows, how many columns? Okay, that we will talk later. Okay, so I think we should talk about that. So why the elements are grouped together in a group, right? Why? So you will find here, let us say, just for example, this is element 1, this is element 2, this is element 3, this is element 4. Sorry, this is element 4. They all have been grouped together in group 4. These all 4 elements have been grouped together in group 4. Why? Because the number of valence electrons in atom of each of these elements is 4. On the basis of number of valence electrons means the electrons which is present in the outermost cell of an atom. For example, as per the structure, how an atom looks like, I will discuss in short. This is the nucleus, and then electron is something which is revolving around the nucleus. So this is as per the modern theory, right, of electrons. So they all have same number of valence electrons. That's why they have fitted together in the same group, right? Because on the basis of the number of the valence electrons, right, the chemical property, chemical reactivity depends of an element, right? Chemical reactivity of an element depends upon the number of valence electrons. Since the number of valence electrons are same, so up to certain extent their properties are similar, right? Properties are similar, right? You will find a trend in boiling points, right? For example, if you consider boiling point, I am writing it in short, BP, boiling point. You might find you might find a trend in the boiling point that down the group boiling point increases, or down the group melting point increases, or you may found in another group, for example here it is x1, x2, x3, and it is pt. These 4 elements have been grouped together in group 2. These 4 elements have been grouped together in group 2. Why? Because all of them have 2 elements, two electrons in their valence shell, right? All of them have 2 electrons in their valence shell, right? So they are pretty much similar in terms of their properties, in terms of their chemical reactivity. So this is how the periodic table have been designed. I will show you in detail with the actual periodic table, right? So now you can try to turn it here. Okay. Yeah, this is the actual periodic table I was talking about. This is the actual periodic table. Is this visual? Okay. So this is the actual periodic table I was talking about. See, it's a grid kind of a structure, right? This is a grid. This is a grid kind of a structure. Okay. This is one cell. This is a unique cell. This is another cell. This is another cell. This is. So you see, you go and find out any element. For example, you talk about phosphorus. Phosphorus. What is the position of phosphorus? Period 1, period 2, period 3. It belongs to third period, right? 3, period number 3. And what is its group number? Group 1, group 2, group 3, group 4, group 5. So this is the group 5 P3, G5 P3. If I tell you the position of phosphorus in the periodic table, you will say it is G5 is a group 5 and period is 3, third period, right? Right, group 5 and period 3. So why these elements are grouped together? Because they have same number of valence electrons. Please bring the letter there. So because they have the same number of valence electrons, on the basis of the number of valence electrons, the chemical properties and physical properties varies, right? So since they all have same number of valence electrons, so that's why they have been grouped together That means they all share similar properties. Similar properties, I am not saying they share same properties. Similar properties means their boiling point, when you arrange the order of the, when you compare the boiling point of group 5 elements, you will definitely find a pattern, right? Either they can be in the increasing order or they are in decreasing order. When you compare the melting point of different elements in this group, right, in the same group, you will definitely find a pattern that they are either in the decreasing order or increasing order, or it can be something unique. If you go with the inert gases, this is called group 8 or group 0. Group 8 or group 0, right? They are same thing. Group 0 because this inert gases are, as the name suggests, they are inert. They are not reactive at room temperature. They are not reactive at room temperature, right? Ordinarily, they don't react with any other substances. Very rarely you will come across compound which is made up of inert gases, right? So this is known as group 8 or group 0. I repeat, this is known as group 8 or group 0. Group 0 we call it because the reactivity of this group 8 element is very low. It is almost inert. So that's why the name is inert gases. Okay. So they don't react. If you go and compare their boiling point, melting point, you will find that the both boiling point and melting point are very low, right? Both are very low. So that's all. I was okay. So how many groups are there in this periodic table? Group 1, group 2. We will leave this elements which are here, which are lying exactly in the middle of this, right? So this is called S block elements. Group 1, group 2. Leave this 10 group, this many elements, okay, and start here. So group 1, group 2, and then group 3, group 4, group 5, group 6, group 7, group 8, or group 0, right? So this is how they have been arranged, okay. So just a moment. So what is that? Have I written down anything? It's the same. So okay, I will show you another periodic table, right? So altogether, how many periodic tables we have? How can you bring that close? Is it visible? Visible? This one, guys. It should be visible now, right? So this is same periodic table with the colored form, okay? Please ignore this numbers. They have been shown for other purpose. Altogether, there are 8 groups in the periodic table. Group 1, group 2, right? And this is not 13, this is 3. Group number 3, group number 4, group number 5, 6, 7, 8. Right? So, are you seeing this light green color? Light green, light green, light green. All of these light green elements are metals. All of these light green elements are called metals. And there is this kind of things. Light yellow kind of thing, right? Light yellow. They are non-metals. And there is pink elements in pink. They are metalloids. They are called metalloids. They lie in between metals and non-metals. So they display both the properties of metals and non-metals. So that's why the name is metalloids. Okay. I think we are just a moment. Okay. So I would like to discuss few more things about periodic table, right? In all together, if I tell you how many elements are there in the periodic table, there are 118 elements. 118 elements. There are 118 elements. 118 elements, and 92 elements are naturally occurring, and rest other elements are man-made. Out of 118 elements, 92 elements are naturally occurring and rest are man-made. Okay. So majority of the elements are solid. Majority of the elements are solid. 11 elements are found in the gaseous state at room temperature. 11 elements are found in the gaseous state at room temperature. 2 elements you will find in liquid state at room temperature. I repeat, 2 elements you will find in liquid state at room temperature. The name of those 2 elements are bromine and mercury. Mercury is a metal and bromine is a non-metal. Bromine falls in this. Okay, so bromine is here. This group is known as halogen group. Group 7, right? Here is bromine. This is a non-metal. See, as per the color coding, this is a non-metal, but it is found in the liquid state in the room temperature, right? Similarly, from the transition metal, you will find an element called Hg, At. Atomic number is 80, right? This is a metal as per the color code, right? And actually it is a metal, right? Which is filled in thermometer. Okay, so this is also a metal. This is an element which is occurs in liquid state at room temperature. Okay, so elements gallium and cesium, yeah, they are very interesting elements. Elements gallium and cesium. Where is gallium? Gallium, gallium, and cesium. Where is cesium? Cs, here. These 2 elements. This is cesium is a metal, right? Cesium is a metal and gallium is also a metal. The atomic number of gallium is 31 and atomic number of cesium is 55, right? They have a very interesting property that they become liquid at a temperature slightly above room temperature. If you consider room temperature as 26 or 27 degrees Celsius, right? Around 35 degrees Celsius they become liquid. So this is the interesting properties of these 2 elements. So I think I am done with the periodic table. So thank you for watching.